Okay, if you're watching this video, my computer just shut off. I was recording it earlier, so I'm just going to really cover what we've done so far. If you need to pause the video and get these notes down, by all means, just pause the video and play it as we go, okay? So this lesson is on skeleton equations, coefficients, and balancing chemical equations. Before my computer lost power, we wrote down what the law of conservation of matter is. Matter cannot be created or destroyed. So Ben, if you put $5 into your bank account, how much will your bank account increase by? If Ben weighs 155 pounds and his backpack weighs 5 pounds, how much will you weigh when you're standing at the scale at Publix with your backpack on? That's it. If you put 4 eggs into the ingredients for cake and you have your finished product, which is the cake, you should have 5 or however many eggs. What did I say? 4 eggs, 5 eggs, whatever. So if you look at this equation that I have circled, we have 1 aluminum. How many atoms of bromine are in Br2, guys? Very good. And then look at the product. How many atoms of aluminum are there? That checks out, but how many atoms of bromine are there? That's not balanced. That's kind of violating the law of conservation of mass. So we're going to fix that. I'm going to teach you how to balance an equation. And so before my computer ran out of power, I was given this definition or this description. To balance an equation, you must find the correct coefficients for chemical formulas in a skeleton equation. And skeleton equations are what we did on Thursday, the previous class for lesson 1. A coefficient is a number written in front of a reactant or product. And they must be whole numbers. So I'm going to give you guys one that you actually, I know you've seen from your freshman bio days. Ready? Watch this. Okay. What does that look like to you? What is that equation for? That is photosynthesis. Very good. Now, I want to share with you what I mean by unbalanced. Ben, I want you to look at the entire reactant side. How many carbon atoms do you see? Very good. 1. Ben, I want you to take a look at the entire product side. How many carbon atoms do you see? Look at that. That is unbalanced. I'm going to teach you how to balance that. We'll get back to photosynthesis momentarily. Let's do our first question. Our first equation, actually. Aluminum plus bromine yields aluminum bromide. Madeline, how many aluminum atoms are there on the reactant side? How many aluminum atoms are there on the product side? That checks out. Okay. Nella, how many bromine atoms are there on the reactant side? And how many are on the product side? Is that balanced? No. I'm going to show you guys how to fix that. It's going to require some very minimal algebra, basic multiplication. So here's what I figured out. When I was in high school, like you guys, I went to tutoring a lot. Chemistry made no sense. And then I don't know what happened. Maybe it's the difference between being 16 years old and 19 years old. Everything just clicked. I remember sitting there in a classroom table and it all just turned on. It was incredible. I'll never forget that feeling. I want you guys to have that feeling now, not when you're 19. I want to do something called a scoreboard. I want you guys to write down the atoms that are present in both sides. And I want you to write a tally for everyone that is present, okay? So Madeline, how many aluminum atoms are present on the reactant side? And how many are on the product side? How many bromine atoms are present on the reactant side? And how many on the product side? 2 and 3. We got a problem. That's not equal. So you guys are going to be adding coefficients in front of certain reactants and products to make everything balanced. Now here's a rule. You can only increase the coefficient. You cannot go down. You cannot subtract. You can't go from 2 to 1 or 3 to 1. You can only go up. And you have to have whole numbers. You can't have 2.5, 2.7. It's got to be 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this right here is our problem. Can you think of a common multiple that 2 and 3 share? 6. Okay. So 2 right here, 2 times what equals 6? Get out a different color. I want you to put a 3 in front of Br2 liquid, bromine. If I now have a 3 coefficient in front of bromine, that number's a coefficient. What is 3 times 2? I want you all to look up at the screen because every second in this matters. Use your eyes that you have. I'll do that again because I saw a lot of you looking down. You multiply the coefficient times the subscript. So what is 3 times 2? You now have 6 bromines on the left. Okay? So Olive, what coefficient should I put in front of aluminum bromide to make my bromines equal 6 on the product side? A 2, but hold on. I know what some of you are thinking. I can feel it. You're thinking, can we squeeze a 2 right in there? The answer is no, you cannot. It is a package deal. AlBr3 is all one compound. So that 2 that Olive said, you are correct. The 2 has to go here. But Mr. Thorson, that's going to ruin the aluminum count. Trust me, it will work itself out in the end. Some of you already see what we're going to have to do. Olive, how many aluminums do we now have on the product side? Correct? How many bromines do we have on the product side? Olive, are the bromines balanced? No. We have 6 here, and we have 6 there. Yeah, they are. Are the aluminums balanced? No. Do you have any suggestion on what we should do to make them balanced? We can only go up. We can't go down. We have 2 aluminums here, 1 here. So what coefficient should I put in front of this aluminum to get it to balance the product side? Put a 2. Put a 2. How many aluminums are on the reactant side now, Olive? Is the entire equation balanced? Yes. So my advice to you guys is do this little scoreboard that I do in trying to make this whole thing equal. And you are in accordance with the law of conservation of mass. So let me show you what I mean by being in accordance with the law of conservation of mass. Evan, now that this is balanced, how many aluminum atoms went into the reaction? And how many came out? Check. How many bromine atoms went in? Atoms, not molecules, atoms. No? Look at this. We got 3 bromines, so it's going to be 1, 2, 3, 4, 5, 6. It's going to be 6. How many came out? Yes. I want to draw this for you guys so you all can actually see this. So pay attention to this. That's aluminum. That's bromine. Okay? Check it out. Here's what we had before. This is unbalanced. And then here's after it's balanced. You must know the difference between an oxygen atom and an oxygen molecule, a bromine atom and a bromine molecule. So I can narrow down where that maybe that little disconnect would be. So let's kind of go here in the side here, guys. Is that a bromine atom or a bromine molecule? That's a bromine molecule. How many bromine atoms make up the molecule? Very good. Here's the gas that we inhale. That's oxygen gas. Is that a molecule or an atom? That's a molecule. How many atoms make up the molecule? Here's the substance called ozone, O3. That's a molecule. How many oxygen atoms make up an ozone molecule? See? So I just need you, I think that's where there might be some disconnect. So when I write this, let's do this again. Is that bromine, is that a bromine atom or a bromine molecule? Good. How many atoms make up the molecule? So far, so good. If I put a 3 coefficient there, listen to my questions. Listen. How many bromine molecules are there? 3. How many bromine atoms are there? There you go. Practice is going to help you out. So let's get to the problem that ruined chemistry for me in high school. I want to see if you can balance that on your own. Hated this. Man, I'm having flashbacks. This is the equation to make water. See if you can get that balance. I'm going to draw it out. Okay. How many hydrogen atoms are on the reactant side? Anyone? Tristan? No. What? Which you said 1 and 2. I need a number. 2. Trey, how many oxygen atoms are on the reactant side? Correct. Alex, how many hydrogen atoms are on the product side? Nella, how many oxygen atoms are on the product side? Right. Now, 16-year-old Thorsten's like, all right, the hydrogen's good. Oxygen, where did the other atom go? I never knew. And then my teacher the next day taught balancing, and I was thinking, of course. Can you guys tell me, where should we put a coefficient first? Go ahead, Connor. You want to put what coefficient do you want to put in front of water? He says the 2. Okay, now you got to do some basic math, Connor. We have 2 times 2 hydrogens. How many total hydrogens will that be on the product side? And then 2 times 1 oxygens. How many total oxygens is that? Is your oxygen problem solved? Right now, it looks good. But Mr. Thorsten, he ruined the hydrogens. They were equal. Now they're not. Trust me, it will work itself out once you do the whole thing. Connor, how can we fix this so the hydrogens are now equal? And what's 2 times 2? Is it balanced? Now it's balanced, guys. So here's how it looks once you're all said and done. That is the actual equation for water. It takes 2 molecules of hydrogen, 1 molecule of oxygen to make water. So can you tell me, what is the ratio of hydrogen to oxygen to water? It's what? It's blank to blank to blank. What is it? 2 to what? 1 to what? 2. Let's go back up to the previous one. What was the ratio of aluminum to bromine to aluminum bromide? Start with how many aluminums were there? 2 to what? How many bromine molecules were there? 3 to what? How many aluminum bromide compounds were there? That's the ratio, 2 to 3 to 2. Now, can 2 to 3 to 2 be reduced? No. So you keep it like that. Can 2 to 1 to 2 be reduced at all? No. Let's do another one. Hydrogen gas reacts with chlorine gas to produce hydrogen chloride gas. This one shouldn't be too hard. Drew, do you see, or let me start over. Drew, is this equation balanced or unbalanced? Do you have any suggestion as to what we should do to get it balanced? Put a coefficient on the product side. What number do you suggest? He says put a 2. Does that balance it, Drew? That was it. So, Drew, what is the ratio of hydrogen to chlorine to hydrogen chloride? 1 to 1 to 2. You guys have to be able to find the ratio. Okay. I think we have time for one more. Oh, we got plenty of time. You're out of here at 11:30. I got 11:18. Good. Okay, here's a tougher one. You ready? Oh yeah, this is going to be good. You don't need to pay attention to the states of matter, solid, liquid, gas, aqueous. That's not your concern today. Okay. Guys, this one's a doozy. So I want to help you, and then I will give you photosynthesis on your own. Let's take this one at a time. Imagine I'm you. This is what I want you to do when you were trying to balance these equations, okay? I need you to first identify every element that you see on the reactant side and on the product side. So Trey, can you tell me all the elements that you see on both sides? Go ahead. Very good. Na. Go on. Just elements if they're on the periodic table. Oxygen, hydrogen, so far so good. Calcium, and very good. Very good. Okay, that's it. That's first step. Just identify what the elements are. Now, Sawyer, can you, I need your help on the reactant side. The reactant side is everything left of the arrow. Sawyer, one element at a time, how many sodium atoms do you see? How many oxygen atoms do you see? How many hydrogen atoms do you see? How many calcium atoms do you see? How many bromine atoms do you see? All right. Olive, product side is everything to the right of the arrow. This is things that are being made. If you guys were absent Thursday and you didn't watch the lesson, you're behind. You need to do that on your own. Olive, how many sodium atoms do you see on the product side? Correct? How many oxygen? Very good. Let me stop there for a second. She distributed the subscript 2 across the parentheses. Very good. How many hydrogens do you see? Good. How many calciums do you see? Very good. Now, everybody, is that calcium inside the parentheses? It is not. So does the 2 apply to the calcium? It does not. And then bromine, how many bromines, Olive? Okay. Jackson, is this equation balanced? It is not. So we need to balance it. So here's my third strategy for you. Step 1, identify the elements like traded. Step 2, identify how many of each one there are, like Sawyer and Olive did. They got 1 sodium, 1 oxygen, 1 hydrogen, 1 calcium, 2 bromines on the left, 1 sodium, 2 oxygens, 2 hydrogens, 1 calcium, 1 bromine on the right. Now what I would suggest you do is you find a side where there is a deficiency. I'll get you started. A deficiency means you have less than what you should have. If you were, if you had a nutrient deficiency, your body doesn't have as many nutrients as it should have. So Jackson, tell me an element on the product side that is at a deficiency when you compare that element to the reactant side? I was hoping you would say bromine. There's one bromine on the product side, two bromines on the reactant side. So where should we put a coefficient and what should that coefficient be? He says it should be a 2. Where should it go? Sodium bromide. Now, I want to also reiterate, you guys cannot squeeze it into here. Not going to happen. You got to put it in front of the whole compound. And again, if you're like, but Mr. Thorson, that ruins the sodium count. It will work itself out. I promise, if you do it right. All right, so Jackson, how many sodiums do you now have on the product side? 2. How many bromines do you now have on the product side? Very good. Okay, let's go to Varun. Varun, can you tell me where there is a deficiency? Okay. What if you didn't hear Varun on the monitor? There's 2 sodiums here. He said there's 1 there. We got to fix that. So Varun, what coefficient do you recommend and where should we put that coefficient? Sodium hydroxide. Okay. So Varun, how many sodiums will you have then? How many oxygens? And how many hydrogens? Is the entire equation balanced, Varun? Yes, it is. Garrett, can you tell me what is the ratio going from left to right of sodium bromide, sodium hydroxide, calcium bromide, calcium hydroxide, and sodium bromide? What is the ratio? Blank to blank to blank to blank. 2 to 1 to 1 to 2. Very good. Okay. Give you guys another one. Practice is really helpful with this. Photosynthesis. CO2 plus H2O yields C6H12O6 plus O2. We have 5 minutes for this one until your bell rings. Kaylin, can you tell me the elements that you see on the left side? Just tell me what the elements are. Carbon, oxygen, anything else? All right. And that's the same for the other side. That's rule number 1. Step 1, actually. Just write down what you see. Okay. Nick, on the entire reactant side, everything there is the reactant side. How many total carbon atoms do you see? How many oxygen atoms do you see? Nope. You got to look at the entire side, Nick. 3 of them. 1, 2, 3. How many hydrogens do you see, Nick? Good. Okay. Joseph, on the product side, how many total carbons do you see? How many hydrogens do you see? How many oxygens do you see? Look at the whole side. Very good. 8. I was afraid you were going to say 6. Okay, clearly this is not balanced. So we need to get it balanced. Anybody have a suggestion as to what we should do first? What coefficient we should use and where it should be put to get this thing balanced out? Give it a look. Alex said a 6. Where do you want to put a 6, Alex? Okay, so if you're watching this video, if you guys are sitting in this class, here's what Alex saw. He sees 6 carbons on the product side. He sees 1 carbon on the reactant side. Alex knows you can't go down. You cannot drop the 6 down to a 1. You got to bring the 1 up to a 6. So he suggests put a 6 in front of this. Okay, this will change our numbers, but again, trust me, it will work itself out when you're all done. Everything will be balanced. Alex, how many carbons will be on the reactant side after you add your coefficient of 6? 1, 2, 3, 4, 5, 6. And how many total oxygen atoms will you now have? We got not 14. No, you got 6 times 2 is 12. Plus this 1 is what? 13. Okay. So, I added an extra carbon, excuse me. So there's 6 there. The carbons look good. Oxygens and hydrogens, not so much. Anybody have a suggestion as to what we should do next? Go ahead, Connor. Aha. Here's what Connor saw. Guys, there are 12 hydrogens on the product side. There are 2 on the reactant side. If you're writing, I really hope you're listening to me. Connor says put a 6 in front of water. Because Connor, what is 6 times 2 going to be? And what will that do to your oxygens? Count the entire reactant side, Connor, not just water. Not 19. You got 6 times 2 over here is 12. 6 times 2. But then you got 6 times 1 there. 18. Okay. You guys have 8 oxygens on the reactant side. Excuse me, on the product side. Any suggestions as what we should do? Our carbons look good. Our hydrogens look good. What should we do to finish it off, Trey? He says put a 6 in front of O2. Trey, what is 6 times 2? Plus another 6? Is it balanced? Yeah. 6, 6, 18, 18, 12, 12. So, Debbie, what is the ratio of every substance here? Okay. Meet me at the door. I'm going to hand you your homework. We will go over it when I see you tomorrow. You may write on this. This is practice that you definitely need. I'll do tomorrow.